Thank you. Hello, everyone. My name is Rodrigo, and I'm here to share with you what APL taught me about Python. Now, by a round of applause, who knows Python here? Pretty good, pretty good. And who knows APL? Weaker, which is good. So let's start with a quote by Alan Perlis that says that a language that doesn't affect the way you think about programming is not worth knowing. And Alan J. Perlis is not some random dude from the internet. It's the guy that won the first quote-unquote Nobel Prize of Computer Science, which is called the Turing Award. And so I'm here to share with you how APL changed the way I think about programming, because there's two things to programming. There's knowing how to think about programming, and then there's the syntax of whatever language you're about to use. And APL impacted, apologies, APL impacted the way I think about solving problems and about writing programs. So what's APL? APL stands for A Programming Language, which is a terrible name, I agree. However, it's important to realize that when APL was invented, it was not a programming language. It was an alternative mathematical notation. And that's why APL is so infamous for its weird looks. Now, dismissing this language just because it looks weird, and not the same thing as biases against humans, but the same line of reasoning applies, it makes no sense. It's as reasonable as dismissing Chinese just because it looks weird, quote unquote, because the characters are different, right? So this is a very interesting language, and I got to program with it for a couple of years, and at some point, I realized, wait, I was writing Python code, and I realized, wait, I'm doing something different. And then I thought about it a lot, and I understood it had been my experience with APL that actually changed the way I write Python code, and I thought that was interesting. And I want to share a very concrete example. Now, the main takeaway for this talk should be explore other languages, play around with them, and the more different they are from Python, the more likely they are to have an impact. And then it's up to you to filter out the good and the bad impact and try to learn from the good things. So, very specific example, this is APL code. If ages is a vector of ages of different people, this is me counting how many people are 18 or over. And the straightforward, basic, simpler way of doing this in Python is with a loop like this, right? And what I'm about to show you is a couple of transformations that step by step should make a lot of sense, but that will lead to something that may look surprising. And it looks surprising to me when I wrote it, and then I realized that I did that whole process in my mind because of my exposure to APL. So first things first, I'll try to create some symmetry here, and I'm either adding 1 or I'm adding 0, so that I have some symmetry. I know that adding 0 is the same as doing nothing, but having it up on the screen makes the next step much easier, which is to realize that you're always adding something. What changes is the amount you add, 1 or 0, that's fine. But now, what you can do is, if you know that booleans and integers are tied together, you can get rid of the ifs, and you just have the condition. I'm not saying this is excellent Python code, I'm just saying this works. And then, well, you can take it one step further, and you can do a sum over a generator expression. Now, again, I'm not saying this is excellent Python code. I'm not saying it's going to pass the code review. I'm just saying that, for some reason, I wrote this down, and I realized it was because of the connection with the APL code, which stands one-to-one. I don't care about the for loop in APL, but the remainder of the things, they're one-to-one. And my exposure to APL made me actually very comfortable with list comprehensions, because suddenly I understood what, to me, list comprehensions are about, or the way I interpret them, my mental model of how they work. And so this is summing. And just one other thing, sum and APL. Now, there's a bunch of built-ins, and they're APL counterparts. And if you see the pattern on the right, this showed me that the functions on the left, they're all related. And I've talked about this in the past. They're all reduced. And I think I need to go.
Yes.
So thank you very much.
Thank you so much. Thank you for that. Okay, let's up here while we are